July 3, 1944, Wright Field, Ohio. The distinctive angular silhouette of a captured Focke-Wulf 190 sat prominently on the tarmac, its fuselage adorned with unfamiliar American markings. Major Robert Cullman of the Air Technical Service Command approached the German fighter with measured steps, his expression a mixture of professional curiosity and barely concealed excitement. This particular aircraft, bearing serial number 670 and nicknamed Black 6 by its German pilot, had been forced down behind Allied lines during the chaotic days following D-Day, and would soon force American test pilots to confront uncomfortable truths about their own aircraft's capabilities against one of the Luftwaffe's most formidable fighters. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Focke-Wulf 190 lay relatively intact on the concrete apron, destined for extensive evaluation by the Army Air Force's Foreign Aircraft Evaluation Unit. Within weeks, this particular machine would be transported to various testing facilities across the United States, where it would undergo systematic assessment against America's frontline fighters, particularly the Republic P-47 Thunderbolt, whose pilots had developed a healthy respect for the German fighter during increasingly fierce aerial combat over Europe. The aircraft would emerge wearing American markings, a bright red tail and yellow wing bands for easy identification. The familiar black crosses had been painted over, replaced with white stars encircled in blue. Following standard American evaluation procedures, this Focke-Wulf was destined for service with one of the military's most specialized units, the Foreign Aircraft Evaluation Program, where it would reveal critical insights about German engineering prowess, combat tactics, and, perhaps most importantly, the relative strengths and weaknesses of American aircraft engaged in the increasingly brutal air war over Europe. The story of how captured enemy aircraft became instruments of revelation for the U.S. Army Air Forces begins not with Cullman's initial inspection on that summer day in Ohio, but with the escalating air battles over Europe and the desperate need for accurate, systematic intelligence about German aircraft capabilities that went beyond the fragmentary combat reports filtering back from frontline squadrons. By mid-1943, American fighter groups faced a complex tactical challenge in the skies over Europe. Despite the considerable skill and courage of individual pilots and the ongoing development of advanced American designs, German fighters continued to exact a heavy toll on bomber formations and their escorts. Luftwaffe pilots flew machines whose true capabilities remained partially mysterious to American commanders, who had to make tactical and strategic decisions based on incomplete information. Intelligence reports from combat pilots provided valuable but fragmentary accounts of enemy aircraft performance. These reports often conflicted with one another and reflected the chaos and confusion of aerial combat rather than systematic, controlled analysis under consistent conditions. Pilots might disagree about the turn radius of a Focke-Wulf at various speeds, its rate of climb at different altitudes, or its acceleration in a dive, all critical factors in developing effective combat tactics. Colonel Harold Watson, an experienced officer with the Air Technical Intelligence Unit, understood that American fighter units needed more than scattered combat reports and second-hand accounts to counter the Luftwaffe threat effectively. They required hands-on experience with captured enemy aircraft, structured opportunities to test these machines under controlled conditions, and systematic evaluation to discover their strengths and vulnerabilities through direct observation and testing. The concept was not new. Both Axis and Allied powers had tested captured aircraft throughout the war, but Watson would organize and systematize the approach in ways that maximized its tactical value. In 1943, following orders from General Henry Hap Arnold, Watson formed what would become known as Watson's Whizzers, a specialized unit tasked with locating, securing, and evaluating captured German aircraft for intelligence purposes. This specialized unit received all repairable captured Axis aircraft that American forces recovered from crash sites across Europe and North Africa. Their mission extended well beyond simple static testing at secure facilities behind the lines. Watson organized comprehensive evaluation programs where captured aircraft would undergo rigorous testing against American fighters, allowing test pilots to examine these machines up close, fly them in controlled conditions, and most importantly, test them in mock combat missions against American fighters. The program addressed a fundamental problem in pilot training that had become increasingly critical as the air war intensified. American fighter pilots trained primarily against their own aircraft, learning tactics optimized for fighting opponents who flew and maneuvered like Americans, using similar aircraft with comparable performance characteristics, and employing tactical doctrines that emerged from shared training foundations. This created a dangerous blind spot when engaging Luftwaffe pilots whose aircraft possessed markedly different performance characteristics, especially regarding roll rate, acceleration, and sustained speed, and whose training emphasized different tactical approaches that leveraged these specific advantages. The recovery operation for German aircraft had become increasingly systematic by 1944, with specialized American evaluation units operating across newly liberated territories. These teams worked with remarkable efficiency to secure crash sites, assess damage, and transport repairable aircraft to centralized evaluation facilities before they could be destroyed or hidden by retreating German forces. The organizational structure reflected American military thoroughness and industrial efficiency. The scale of Allied air operations over Europe made captures inevitable through sheer statistical probability. With thousands of sorties flown monthly by German forces, mechanical failures, battle damage, navigation errors, fuel exhaustion, and weather-related incidents resulted in numerous forced landings on Allied-controlled territory. Not all of these aircraft were destroyed on impact or rendered irreparable by crash damage. Some pilots, recognizing their situation was hopeless, executed controlled crash landings that left their machines largely intact, sometimes even with minimal structural damage that could be repaired with available resources and components. The specific Focke-Wulf 190A4 that captured Major Cullman's attention that summer day fell into this category of repairable captures. The aircraft had sustained damage during intense fighter operations, supporting German ground forces in Normandy, forcing an emergency landing in territory that had been overrun by Allied forces following the D-Day landings. American recovery teams reached the site within hours, following established procedures for evaluating crash sites. They examined the Focke-Wulf carefully, assessed the extent of damage, and determined that despite battle damage and crash impact, the airframe remained sufficiently intact for repair and restoration to flight-worthy condition. The aircraft was carefully loaded onto a specialized transport and sent first to England, then across the Atlantic to Wright Field, Ohio, where experienced technicians and engineers worked systematically to restore it to flying condition. Wright Field, which served as America's primary facility for evaluating new aircraft designs and conducting detailed testing of captured enemy types, included extensive workshops equipped with specialized tools, comprehensive test ranges for various evaluation protocols, and runways specifically configured for evaluation flights under controlled conditions. Technicians at Wright Field possessed considerable skill in reverse engineering and repairing Axis aircraft, despite lacking original technical manuals, factory specifications, and genuine spare parts manufactured to original tolerances. The repair process for the captured Focke-Wulf required substantial ingenuity and resourcefulness that spoke to both American technical competence and industrial capability. Technicians worked with fragments of information gleaned from intelligence reports, photographs, and earlier technical assessments of other captured German aircraft to understand the complex systems of the FW-190. The BMW 801D2 radial engine, a sophisticated 14-cylinder power plant that produced approximately 1,700 horsepower, underwent detailed inspection and necessary repairs. This engine represented a significant technological achievement, delivering substantial power through its sophisticated engineering systems. The aircraft's two 20mm MG-151 cannons mounted in the wing roots and the two 13mm MG-131 machine guns in the cowling were removed as per. Standard American procedures for testing captured aircraft. Control surfaces were thoroughly examined for structural integrity and proper operation. Hydraulic systems underwent pressure testing and inspection for leaks. Fuel tanks were carefully inspected for damage, cracks, and potential leak points that could cause catastrophic failure during flight operations. After weeks of meticulous work by skilled technicians, the Focke-Wulf was declared ready for initial test flights. American test pilots approached their first encounters with captured German fighters with professional curiosity, mixed with considerable skepticism born from years of combat reports. Official information had consistently portrayed German aircraft as technically sophisticated, but often temperamental machines that prioritized high performance over reliability, emphasizing engineering sophistication rather than practical combat durability. The prevailing view among many American pilots, reinforced by official communications, held that German engineering focused on producing exceptional performance that could not be sustained under actual combat conditions due to maintenance challenges and mechanical fragility. These comfortable assumptions began dissolving rapidly the moment experienced American test pilots climbed into the Focke-Wulf's cockpit and experienced firsthand what German designers and engineers had actually achieved through careful design, sophisticated engineering, and meticulous attention to combat requirements. Cockpit layout of the FW-190 immediately impressed American pilots familiar with the relatively spacious accommodations of Republic P-47s and North American P-51s. Despite its smaller overall dimensions, the Focke-Wulf cockpit demonstrated thoughtful ergonomic design, with controls logically arranged and positioned within easy reach, reducing pilot workload and allowing concentration on tactical situations rather than struggling with aircraft systems. Instruments were clearly marked with easily readable gauges and sensibly grouped by function, following human factors, principles that prioritized pilot effectiveness. The seat provided good visibility, an important consideration during high-stress combat where situational awareness could mean the difference between victory and defeat. Visibility, with the canopy closed, exceeded what many American pilots expected, though the structural framework still created some blind spots that could be exploited in combat. But the true revelation came when American test pilots advanced the throttle and felt the BMW 801 radial engine respond with smooth, progressive power delivery. The power built steadily and predictably as the Focke-Wulf accelerated down Wright Field's runway, the three-bladed VDM constant-speed propeller biting efficiently into the air. The takeoff roll was noticeably shorter than expected for an aircraft of the FW-190's weight and size, clear testimony to the engine's substantial power output and the airframe's efficient aerodynamic design that minimized drag throughout the speed range. Once airborne, the Focke-Wulf demonstrated handling characteristics that fundamentally challenged everything American pilots thought they understood about German aircraft design philosophy and engineering capabilities. The flight controls were beautifully harmonized with aileron, elevator, and rudder forces, well balanced across the entire speed range, from approach speeds to maximum velocity. Control forces increased predictably with speed, providing good feedback without becoming excessively heavy, and decreased smoothly at lower speeds without becoming overly sensitive or twitchy. The Focke-Wulf responded crisply and predictably to control inputs without displaying the oversensitivity that plagued some fighters. Roll rate exceeded that of most American fighters significantly, allowing rapid changes in flight direction that were critical for both offensive and defensive maneuvering in combat. The aircraft could be flown aggressively through various maneuvers without displaying any troubling tendency toward departure from controlled flight, spin entry, or other dangerous characteristics that could prove fatal in combat situations. American test pilots systematically evaluated the Focke-Wulf's performance envelope through carefully planned test flights, pushing the aircraft through standardized maneuvers, specifically designed to reveal its strengths, limitations, and any hidden dangerous characteristics. Climb performance impressed them considerably and generated significant concern about tactical implications against certain American fighters. The W-190A4 could maintain excellent climb rates at lower altitudes, where its radial engine produced its best power. This performance advantage diminished progressively as altitude increased, with the engine losing efficiency in the thinner air above 20,000 feet, a characteristic that would prove critically important in subsequent comparative testing. High-altitude performance particularly concerned American pilots and tactical planners because bomber formations typically operated between 25,000 and 30,000 feet. This altitude regime required escort fighters capable of effective combat at those heights, and preliminary testing suggested the Focke-Wulf would struggle against certain American fighters above 20,000 feet, especially in sustained climbing engagements. The revelation proved reassuring to pilots and commanders who understood the implications for escort tactics. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Speed trials conducted under controlled conditions at various altitudes confirmed a more complex picture than combat reports had suggested. The FW-190 could achieve approximately 390 miles per hour at optimal altitude with the engine running at military power settings, competitive but not superior to the latest American fighters. However, its acceleration at lower altitudes proved exceptional, allowing German pilots to quickly build energy when needed. Wing design gave the Focke-Wulf its distinctive appearance and delivered exceptional roll performance. Though American engineers noted that the wing generated substantial lift with minimal drag compared to some earlier designs, significantly contributing to the aircraft's remarkable roll rate and responsive handling. This wing design maintained its effectiveness across a remarkably broad speed range, from relatively low-speed handling during landing approaches through high-speed performance during combat maneuvering, providing consistent, predictable handling characteristics that reduced pilot workload and enhanced combat effectiveness. Dive performance revealed an area where the Focke-Wulf initially seemed to demonstrate clear superiority over some American fighters. The aircraft could dive at very high speeds without encountering the severe control stiffening and reduced control effectiveness that plagued many fighters when approaching or exceeding their maximum design speeds. Pilots could pull out of steep, high-speed dives without requiring excessive physical effort, and the airframe remained stable throughout the maneuver without tendency toward flutter, buffeting, or structural failure at typical combat speeds. American test pilots noted this capability with particular interest because diving attacks represented a primary German tactical doctrine for engaging bomber formations and escorting fighters, attacking from altitude to build speed and energy before pulling back up. The Focke-Wulf's ability to execute high-speed dives with excellent control authority throughout the maneuver represented a significant tactical advantage against certain American fighters, but not all of them, as subsequent testing would dramatically reveal. Turn performance presented a more complex and nuanced picture that required careful analysis. The Focke-Wulf could not match the sustained turn rate of the Spitfire in level flight at moderate speeds, nor could it outmaneuver the agile P-51 Mustang in extended turning engagements. However, American pilots discovered through systematic testing that the FW-190's exceptional roll rate allowed skilled pilots to use rolling scissors and maneuvers and vertical reversals effectively, compensating for its less impressive sustained turning capability. The Focke-Wulf's structural strength and robust construction impressed American engineers who examined the airframe in systematic detail. The aircraft was substantially built with significant safety margins engineered into critical structural components throughout the airframe. This robust construction philosophy contrasted markedly with some American design approaches, but aligned well with others, particularly the Republic P-47 Thunderbolt, which similarly emphasized structural strength. The FW-190 could sustain significant battle damage and still return to base, a capability that directly translated into pilot survival rates and aircraft availability for subsequent missions. German engineering philosophy clearly emphasized survivability and durability, accepting somewhat higher empty weight in exchange for ruggedness that kept aircraft and pilots in combat longer. Following these initial evaluations, The Air Technical Service Command organized a series of comparative tests, pitting the captured Focke-Wulf against America's frontline fighters, the Republic P-47 Thunderbolt, the North American P-51 Mustang, and the Lockheed P-38 Lightning. These tests would answer critical questions about relative performance and help develop tactical recommendations for American pilots engaging FW-190s in combat. The comparative tests began at Wright Field, but eventually expanded to include evaluations at various altitudes over Edwards Field in California and high-altitude testing in Colorado to simulate combat conditions across the full spectrum of operational environments. The test program was designed to evaluate each aircraft's performance in specific scenarios, most relevant to actual combat situations reported by operational squadrons in Europe. Captain James Howard, an experienced P-47 Thunderbolt pilot with combat experience against the Luftwaffe, was selected to fly mock combat missions against the captured Focke-Wulf. Howard had encountered 4 190s in actual combat and possessed the tactical knowledge necessary to evaluate the aircraft's performance accurately. He would fly the P-47 while Major Williams Bradford, an equally experienced test pilot, flew the captured German fighter. The comparative testing began with basic performance measurements, acceleration, climb rate, top speed, and turn radius before progressing to simulated combat scenarios. Each aircraft's performance was meticulously documented using calibrated instruments, gun cameras, and ground observation posts to eliminate subjective impressions and provide concrete data for tactical analysis. Initial tests at lower altitudes confirmed many combat reports. The Focke-Wulf demonstrated exceptional acceleration, superior roll rate, and excellent controllability below 15,000 feet. In simulated dogfights starting from equal energy states at 10,000 feet, the German fighter consistently gained the advantage in the first 30 seconds of engagement, using its superior roll rate and acceleration to achieve positional advantage. Howard found his P-47 Thunderbolt struggling to match the Focke-Wulf's responsiveness in the dense air at lower altitudes. The heavier American fighter, weighing nearly 13,000 pounds compared to the FW-190's approximately 8,000 pounds, couldn't match the German aircraft's initial acceleration or roll performance. Howard had to employ careful energy management and exploit the P-47's excellent dive acceleration to evade the more agile Focke-Wulf. As testing progressed to medium altitudes around 20,000 feet, the performance gap began narrowing. The Thunderbolt's turbocharged Pratt & Whitney R2800 radial engine maintained its power output more effectively as altitude increased, while the Focke-Wulf's BMW engine began losing efficiency in the thinner air. Howard found his aircraft's climb performance improving relative to the German fighter, though the FW-190 still maintained its superior roll rate and initial acceleration advantage. The most dramatic revelations emerged during high-altitude testing, conducted between 25,000 and 30,000 feet, the critical altitude regime where American bomber formations operated and where escort fighters needed to perform effectively. At 28,000 feet, the performance equation shifted dramatically in the Thunderbolt's favor. The P-47's turbocharged engine continued delivering substantial power over 2,000 horsepower, while the Focke-Wulf's normally aspirated BMW radial struggled in the thin atmosphere, producing barely 50% of its sea-level output. Howard found his Thunderbolt could now outclimb the German fighter by a significant margin, accelerate more quickly, and maintain higher sustainable speeds. Most significantly, when both aircraft entered diving attacks from 28,000 feet, the Thunderbolt demonstrated a startling superiority that contradicted earlier lower-altitude tests. From identical starting positions at 28,000 feet, both pilots would push their aircraft into steep dives, accelerating rapidly toward the ground. In every test repeated numerous times with different pilots to eliminate individual technique variables, the P-47 pulled away from the Focke-Wulf, opening the distance between them throughout the dive. The P-47's superior power-to-weight ratio at altitude combined with its clean aerodynamic design and robust structure that resisted compressibility effects at high speeds, allowed it to accelerate more rapidly in the dive than the Focke-Wulf, despite the American fighter's greater weight. By the time both aircraft reached 20,000 feet in the dive, the Thunderbolt had typically gained several hundred yards of separation, a decisive advantage in combat that would allow the American pilot to either extend away safely or reverse into a climbing attack that the German fighter couldn't match. This diving superiority at high altitudes represented a critical tactical advantage that hadn't been fully appreciated by American fighter pilots. The test results demonstrated conclusively that while the Focke-Wulf possessed significant advantages at lower altitudes, the Thunderbolt could establish decisive superiority by initiating combat from high altitude and using its diving performance to control engagements. Captain Howard documented these findings in detailed reports, noting, "The P-47 Thunderbolt consistently outdives the Focke-Wulf 190 when initiating from altitudes above 25,000 feet. This performance advantage appears most pronounced starting from 28,000 feet, where the Thunderbolt pulls away from the German fighter throughout the dive phase, creating separation that cannot be closed by the FW-190. This characteristic should be exploited tactically by maintaining altitude advantage whenever possible and initiating combat with diving attacks that capitalize on the P-47's superior high-altitude performance." The mock combat sessions proved invaluable for developing specific tactical recommendations for operational squadrons. Howard and his fellow test pilots systematically explored various engagement scenarios, testing different tactical approaches and documenting their effectiveness against the captured Focke-Wulf. They identified specific vulnerabilities in the German fighter that could be exploited by American pilots, particularly its deteriorating performance at high altitudes and its vulnerability to high-speed diving attacks initiated from above. The detailed test results were compiled into tactical bulletins distributed to fighter groups operating in the European theatre. These bulletins provided concrete performance data, optimal engagement parameters, and specific recommendations for P-47 pilots encountering Focke-Wulf 190s in combat. The guidance was clear: maintain altitude advantage whenever possible, initiate combat with diving attacks from above 25,000 feet, avoid sustained turning engagements at lower altitudes, and exploit the Thunderbolt's superior high-altitude performance and diving capability. Following these controlled evaluations at Wright Field, the test program expanded to include operational demonstrations at various training bases across the United States. The captured Focke-Wulf, along with American fighters used in the comparative testing, traveled to these bases to conduct live demonstrations for pilots preparing to deploy to combat theaters. At each stop, the demonstration team would establish temporary operations and set up comprehensive briefings, showing American pilots exactly what German aircraft could do in flight and teaching them specific tactics designed to counter Luftwaffe strengths while identifying and exploiting whatever weaknesses had been found through systematic testing. The demonstrations typically began with static displays where pilots could examine the captured Focke-Wulf up close, inspect its cockpit layout and controls, and develop a concrete understanding of the machine they would face in combat. Then came flight demonstrations where experienced test pilots would fly the captured aircraft through carefully choreographed aerobatic routines and tactical maneuvers, demonstrating specific performance capabilities in ways that were far more effective than written reports or verbal briefings could ever be. For the Focke-Wulf demonstrations, test pilots would perform high-speed passes at low altitude to show the aircraft's excellent acceleration and responsiveness. They would execute rapid rolling maneuvers to display the FW-190's exceptional roll rate that allowed it to change direction quickly in combat. They would demonstrate the aircraft's maneuverability through a series of combat-relevant maneuvers, showing both its strengths and the limited circumstances under which American fighters retained advantages. Mock dogfights against American fighters would illustrate both the Focke-Wulf's strengths and the specific tactics that proved most effective against it. These dynamic demonstrations, conducted before audiences of pilots preparing for combat deployments, provided invaluable practical education that translated directly into improved combat effectiveness and reduced casualties once these pilots reached operational theaters. The most valuable and impactful component of these base visits involved the mock combat sessions, where captured German fighters would engage American fighters in carefully controlled, simulated combat under observation. Selected experienced American pilots would fly their own operational aircraft against the captured Focke-Wulf, experiencing firsthand how the German fighter handled in dynamic combat situations and learning what worked and what proved ineffective against it. One such demonstration took place at Wright Field in Florida during late 1944 as the air war over Europe reached its peak intensity. The base commander had arranged for several of his most experienced instructors to fly mock engagements against the captured Focke-Wulf to gain practical knowledge they could pass on to trainees preparing for deployment to Europe. The American test pilot flying the FW-190 demonstrated tactics that German pilots typically employed in actual combat, using the fighter's strengths in acceleration and roll rate to maintain energy throughout the engagement, while avoiding situations where American fighters held the advantage. American pilots flying P-47 Thunderbolts attempted various tactics against the Focke-Wulf, discovering through direct experience the optimal approach for engaging this formidable opponent. They quickly confirmed the test results from Wright Field. When combat began below 20,000 feet, the Focke-Wulf could often gain an initial advantage through superior acceleration and roll rate. However, when engagements started above 25,000 feet, particularly around 28,000 feet, the P-47 could establish decisive control through superior power and diving performance. The mock combat sessions proved invaluable for American pilots who had only encountered the Focke-Wulf in actual combat, where the chaos and confusion of battle made systematic assessment difficult. Directly observing and experiencing the German fighters' performance capabilities in controlled combat maneuvering demonstrated clearly that American pilots flying P-47s possessed significant and fundamental tactical advantages when they maintained altitude advantage and initiated combat on their terms. This pattern of revelation and gradually dawning understanding repeated itself across numerous training bases where the demonstration team conducted their presentations throughout late 1944 and into 1945. American pilots received practical education about German aircraft capabilities during pre-deployment training, then experienced combat demonstrations that converted abstract knowledge into practical tactical understanding. The captured aircraft demonstrations provided concrete, undeniable evidence about the relative capabilities of American and German fighters, allowing pilots to develop appropriate tactical approaches before facing the life-or-death reality of actual combat. Lieutenant General Jimmy Doolittle, who commanded the 8th Air Force during this period, later wrote about the value of these captured aircraft evaluation programs in his memoirs, though historians note that some technical details in his accounts must be treated cautiously. He described how captured German fighters provided invaluable intelligence that directly influenced tactical doctrine and training programs. Formation leaders received opportunities to observe captured aircraft in flight and participate in mock combat sessions, allowing them to understand German aircraft characteristics through direct experience rather than relying solely on second-hand reports and intelligence briefings. Doolittle emphasized the substantial value of this training, noting that familiarity with enemy aircraft capabilities represented a factor not to be underestimated in aerial combat, where split-second decisions often determined survival. Following these demonstration sessions, flight leaders would conduct detailed training lectures with their squadron members, passing along specific recommendations and tactical insights based on their personal observations and direct experience with captured German aircraft. This systematic knowledge transfer helped prepare American pilots for combat encounters with more realistic understanding of both German strengths and the specific circumstances under which American fighters retained exploitable advantages. The program achieved increasingly positive results by late 1944 as American pilot training incorporated lessons learned from the evaluation program. Squadron tactics evolved to exploit identified German vulnerabilities, and new pilots deployed to combat theaters with much more sophisticated understanding of enemy capabilities. The technical intelligence gathered from captured Focke-Wulfs extended well beyond simple flight testing and combat evaluation. American engineers at Wright Field systematically disassembled FW-190 components to understand German manufacturing techniques, material selections, and detailed design approaches. They examined the wing structure and airfoil sections in meticulous detail, studying the construction methods and attempting to understand precisely how German designers had achieved such responsive handling characteristics. They analyzed the BMW 801 engine with great interest, noting its sophisticated engineering and efficient power delivery. The fuel system received careful attention, as engineers attempted to understand how German designers had optimized performance with increasingly limited resources. The hydraulic systems were evaluated for their reliability and relative ease of maintenance compared to American systems. American engineers noted repeatedly the consistently high quality of materials used throughout the aircraft, despite Germany's increasingly severe resource constraints. German access to specialized aluminum alloys, high-grade steels, and precision manufacturing capabilities allowed designers to create structures that effectively combined strength with acceptable weight while maintaining production efficiency, even under the increasingly difficult circumstances of the late war period. The investigation of captured Focke-Wulfs revealed sophisticated manufacturing techniques that enabled mass production while maintaining high-quality standards. German factories produced FW-190s using assembly line methods that maintained remarkably tight tolerances and consistent quality across thousands of individual aircraft, despite the challenges of dispersed production and strategic bombing. The captured Focke-Wulf, designated FE-190 Foreign Equipment 190, served with the evaluation program until February 1945, when the aircraft was damaged beyond repair during a Maid-Olov routine test flight. By that point, in its second operational life, the aircraft had traveled extensively across the United States, visiting numerous training bases and providing direct hands-on education to hundreds of American pilots who gained invaluable first-hand knowledge of German aircraft capabilities. Other captured FW-190s served similar evaluation and demonstration roles. American records and post-war research indicate that at least 5 Focke-Wulf 190s definitely operated with the Foreign Aircraft Evaluation Unit at various times during 1944 and 1945. Documentation indicates that several captured FW-190s were used at various training fields across the United States to train American pilots on effective tactics against German fighters. This transfer of tactical knowledge reflected recognition that the Focke-Wulf represented a significant and persistent threat, requiring specialized counter-tactics that needed to be disseminated widely throughout the training pipeline. The training emphasized maintaining high altitude whenever possible, using superior diving performance to control engagements, and avoiding extended turning fights at lower altitudes where the German fighter retained advantages. The broader implications of American pilots directly experiencing and thoroughly understanding captured German fighters extended well beyond immediate tactical considerations. The evaluation program established conclusively that while German aircraft, like the Focke-Wulf, possessed significant advantages in certain performance categories, American fighters, particularly the high-altitude performers like the P-47 Thunderbolt, held decisive advantages in the specific combat regimes where bomber escort operations occurred. This understanding boosted confidence among American pilots deploying to combat theaters and helped refine tactics to maximize existing advantages rather than attempting to match the German fighters in categories where American designs held inherent disadvantages. Production numbers told a compelling story about relative industrial capacity that reinforced these tactical findings. By late 1944, American factories were producing approximately 500 P-47 Thunderbolts monthly, eventually reaching over 15,000 total aircraft produced. This output significantly exceeded German production of Focke-Wulf 190s, creating an increasingly favorable numerical advantage for Allied forces that complemented the tactical advantages identified through the evaluation program. Moreover, these Thunderbolts were equipped with reliable engines built to consistent quality standards, sophisticated and accurate instruments, and radio equipment that worked consistently and reliably. American pilots flew aircraft that had been properly maintained by well-trained ground crews with adequate supplies of genuine spare parts, proper tools, and technical manuals. The quality and thoroughness of American pilot training also became increasingly apparent through the evaluation program. American pilots typically arrived at operational units with 200 to 400 hours of total flight training time, including extensive instruction in advanced combat tactics, instrument flying under various weather conditions, and formation procedures. German pilot training had been dramatically shortened by late 1944 due to severe fuel shortages and the loss of training facilities and experienced instructors. New Luftwaffe pilots sometimes arrived at frontline units with barely 100 hours total flight time, minimal combat training, and often no instrument training whatsoever, leaving them dangerously unprepared for the reality of combat operations. These inadequately trained pilots faced veteran American pilots flying increasingly well-understood combat tactics, a combination that produced grimly predictable results reflected in German loss statistics during the final year of the war in Europe. Some American test pilots who extensively flew captured FW-190s through multiple test flights and mock combat engagements developed grudging professional respect for German engineering prowess and design philosophy. They recognized through direct experience that the Focke-Wulf represented a coherent, well-integrated design that intelligently prioritized the characteristics most valuable for its intended tactical mission. The aircraft deliberately optimized certain characteristics like roll rate and low-altitude acceleration that served its primary mission of bomber interception, accepting compromises in sustained high-altitude performance. This represented sound engineering judgment that selected appropriate design compromises to achieve clearly defined mission objectives, rather than pursuing theoretical performance maxima that didn't serve actual operational requirements. The captured Focke-Wulf testing program represented a sophisticated and systematic approach to tactical intelligence gathering that directly improved combat effectiveness for American fighter pilots. By thoroughly understanding German fighter capabilities through controlled testing and mock combat, American pilots could develop optimal tactical approaches that maximized their own aircraft strengths while avoiding situations that played to German advantages. The specific finding that P-47 Thunderbolts could consistently outdive Focke-Wulf 190s when starting from 28,000 feet proved particularly valuable for escort tactics. It allowed Thunderbolt pilots to maintain altitude advantage above bomber formations, then use their superior diving performance to attack German interceptors from above, a tactic that exploited the P-47's greatest strength against one of the Luftwaffe's most formidable fighters. The Focke-Wulf 190, captured in Normandy following D-Day, had an extraordinary second life as an instrument of tactical education for American pilots. From a crashed fighter lying in a French field, it became a vital source of intelligence that directly influenced combat tactics, pilot training, and operational doctrine. The aircraft served this important educational role until its loss in February 1945, having traveled extensively across the United States and provided hands-on experience and realistic assessment to hundreds of Army Air Forces personnel. The story of captured German aircraft in American service illustrates the sophisticated and professional approach the U.S. Army Air Forces took toward understanding enemy capabilities. Rather than relying solely on fragmentary combat reports and intelligence assessments of uncertain reliability, American forces invested significant resources in recovering, repairing, and systematically flying captured German aircraft under controlled conditions. This systematic approach to tactical intelligence gathering represented best practices for military organizations seeking to understand opponent capabilities accurately. The Foreign Aircraft Evaluation Program demonstrated that comprehensive intelligence gathering, professional competence, and systematic analysis could provide decisive advantages by identifying specific tactical approaches that maximized existing capabilities. American pilots who flew against captured Focke-Wulfs in mock combat gained valuable knowledge about aircraft characteristics and optimal tactics. That hard-won knowledge confirmed what many already understood from combat experience. While German aircraft possessed significant performance advantages in certain regimes, American fighters, particularly the high-altitude capable P-47 Thunderbolt, held decisive advantages in the specific circumstances most relevant to the strategic bombing campaign. The experience of American test pilots confronting the Focke-Wulf's capabilities and developing effective counter-tactics parallels the broader Allied military experience during World War II's latter stages. Initial respect for German technological sophistication gradually gave way to recognition that Allied forces possessed decisive advantages in multiple critical areas: industrial capacity, access to strategic resources, training, infrastructure, and increasingly sophisticated tactical doctrine that matched or exceeded German capabilities. The Focke-Wulf represented one particularly visible manifestation of German technical excellence. German designers had created an aircraft that excelled at its intended tactical mission of intercepting bomber formations. German industry produced it in substantial numbers with consistent quality, despite increasingly severe resource constraints. However, systematic American evaluation revealed specific vulnerabilities that could be exploited through proper tactics, particularly the FW-190's deteriorating performance at high altitudes and its inferior diving capability, compared to the P-47 Thunderbolt when starting from 28,000 feet. American forces could study, analyze, and understand these characteristics through programs like the Foreign Aircraft Evaluation Unit, then develop specific tactical approaches that maximized existing advantages. The technical sophistication of the FW-190 impressed American engineers and pilots who examined it thoroughly. The aircraft represented advanced aerodynamic research successfully implemented in high-volume production. The BMW 801 engine demonstrated sophisticated engineering despite its high-altitude limitations. The aircraft's systems integration reflected careful design that successfully balanced multiple competing requirements to create a coherent, effective weapon system optimized for its intended mission. American pilots who flew the Focke-Wulf extensively developed professional respect for German engineering capabilities. They experienced firsthand an aircraft that handled beautifully across most of its flight envelope, performed superbly in its intended tactical role, and demonstrated thoughtful, competent design throughout every system. This direct experience forced acknowledgement that German technical capabilities deserved serious respect and equally serious tactical countermeasures based on thorough understanding rather than assumptions or wishful thinking. The systematic evaluation of captured German aircraft succeeded in large part because it identified specific, exploitable weaknesses that American pilots could target through appropriate tactics. The discovery that P-47 Thunderbolts could consistently outdive Focke-Wulf 190s when starting from 28,000 feet provided a concrete tactical advantage that directly translated into combat effectiveness. By maintaining altitude advantage and initiating combat with diving attacks, Thunderbolt pilots could engage on favorable terms, exploiting their aircraft's superior high-altitude performance and diving capability. This tactical approach allowed American fighters to impose their preferred combat geometry rather than accepting engagements on terms favorable to the more maneuverable German fighters. The U.S. Army Air Forces conducted extensive technical evaluation of captured FW-190s at multiple facilities, with particularly detailed performance testing occurring at Wright Field, where American engineers created comprehensive technical reports documenting German fighter capabilities in systematic detail. These evaluations measured speed at various altitudes, climb rate throughout the altitude range, acceleration in different flight regimes, and handling characteristics across the complete performance envelope under controlled test conditions. American engineers created detailed technical reports documenting all findings, comparing Focke-Wulf performance directly with American fighter types under equivalent conditions, and analyzing specific design features that contributed to observed performance. These technical reports circulated within American aviation circles, informing aircraft designers about German technical approaches, providing tactical planners with accurate performance data, and giving operational commanders realistic assessments of German capabilities for use in tactical decision-making. The reports confirmed what mock combat testing had revealed. While the Focke-Wulf possessed significant performance advantages in certain categories, particularly at lower altitudes, the P-47 Thunderbolt established decisive superiority at high altitudes, especially in diving performance, when starting from 28,000 feet. The systematic analysis highlighted specific performance characteristics that could be exploited tactically by American pilots, providing concrete recommendations that directly influenced combat operations over Europe. Lieutenant Thomas Fraser, the original FW-190 pilot, whose emergency landing in Normandy delivered this valuable intelligence asset to American forces, likely never knew the substantial impact his aircraft would have on Allied tactical development. From its forced landing on D-Day to its eventual loss during testing in February 1945, this particular Focke-Wulf served as a crucial instrument of tactical education for American pilots, concretely demonstrating German engineering capabilities and allowing the development of specific counter-tactics that maximized existing American advantages. The aircraft served this important educational role for nearly 8 months, traveling extensively across the United States and providing hands-on experience and realistic assessment to hundreds of Army Air Forces personnel. The story of captured German fighters in American service illustrates the sophisticated and professional approach the U.S. Army Air Forces took toward understanding enemy capabilities despite the pressure of global war. Rather than relying solely on fragmentary combat reports and intelligence assessments of uncertain reliability, American forces invested significant resources in recovering, repairing, and systematically flying captured German aircraft under controlled conditions. Approach to tactical intelligence gathering represented best practices for military organizations seeking to understand opponent capabilities accurately and develop effective countermeasures. The Foreign Aircraft Evaluation Program demonstrated that thorough intelligence gathering, professional competence, and systematic analysis could provide decisive advantages on the battlefield by identifying specific tactical approaches that maximized existing capabilities while minimizing exposure to enemy strengths. American pilots who flew against captured Focke-Wulfs in mock combat gained valuable knowledge about aircraft characteristics and optimal tactics. That hard-won knowledge provided concrete tactical guidance. Maintain altitude, exploit the P-47's superior high-altitude performance, and use diving attacks initiated from 28,000 feet to establish decisive control of engagements against one of the Luftwaffe's most formidable fighters. This knowledge directly translated into improved combat effectiveness and reduced casualties, as American fighter groups incorporated these lessons into their operational tactics during the final phases of the air war over Europe. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe. I'll use the web search tool to gather more historical information for the final section of this World War II script. Let me create a comprehensive, historically accurate final section to complete this World War II historical script about US testing of captured FW-190 and the P-47's diving capabilities. As 1944 progressed toward its final months, the significance of the comparative aircraft testing program expanded beyond the confines of Wright Field and the various training bases across the United States. The tactical intelligence gleaned from systematic evaluation of the captured Focke-Wulf 190 against the Republic P-47 Thunderbolt began filtering directly to operational fighter groups in the European theatre. Colonel Hubert Zemke's elite 56th Fighter Group, the famed Wolfpack, would be among the first to fully integrate these findings into their combat tactics, with devastating effectiveness against the Luftwaffe. Zemke, a brilliant tactical innovator who had earned the Distinguished Service Cross for his leadership, developed a comprehensive briefing program based on the comparative testing results, emphasizing the critical altitude threshold at 28,000 feet, where the Thunderbolt's performance advantages became decisive. His pilots now understood with newfound clarity that what many had discovered through trial and error in actual combat had been scientifically verified through systematic testing. The P-47 could consistently outdive any German fighter when starting from high altitude, creating a tactical advantage that could be exploited repeatedly if pilots maintained proper energy management. Lieutenant Colonel Francis Gaby Gabreski, the 56th Fighter Group's leading ace who would eventually claim 28 aerial victories, incorporated these tactical insights into the group's operational doctrine. The intelligence from Wright Field confirmed what we'd been learning the hard way, Gabreski later wrote in his memoir. The early P-47s with those thin propellers couldn't match a Focke-Wulf at low altitude, but once we got water injection and paddle blade props in the spring of '44, we had a completely different machine. Above 25,000 feet, we owned the sky. The key was understanding exactly where that performance crossover happened and making sure we fought on our terms, not theirs. The practical application of this tactical intelligence manifested dramatically during a massive air battle over Germany on November 20th, 1944. The 8th Air Force launched over 1,000 bombers against synthetic oil plants at Leuna and Merseburg, accompanied by fighter escorts, including 5 squadrons of P-47 Thunderbolts from the 56th and 78th Fighter Groups. Intelligence reports had warned of substantial Luftwaffe opposition, with German fighters expected to mass for desperate defensive action against this threat to their critical fuel supplies. Major Robert Johnson, who would end the war as the second highest scoring P-47 ace with 27 confirmed victories, led a 16-ship formation of Thunderbolts at 30,000 feet, well above the bomber stream they were tasked to protect. Johnson had absorbed the tactical lessons from the Wright Field testing program through Zemke's briefings and positioned his formation specifically to exploit the Thunderbolt's high-altitude performance advantages. German radar detected the incoming bomber formation, and Jagdgeschwader 3 scrambled 30 Focke-Wulf 190s to intercept, climbing from their base near Frankfurt toward the advancing bomber stream. Johnson spotted the German fighters climbing through 22,000 feet and immediately recognized the tactical opportunity. Rather than waiting for the German formation to reach its optimal combat altitude, he committed his Thunderbolts to a coordinated high-speed diving attack, while the Focke-Wulfs remained at an energetically disadvantageous position. "I remember that moment with absolute clarity," Johnson recounted after the war. "We'd been briefed extensively on the testing results from Wright Field, and I knew with complete confidence that if we engaged from above 28,000 feet, our Thunderbolts would accelerate away from the 190s in the dive. We had 16 jugs against 30 Focke-Wulfs, but I knew the altitude gave us the decisive advantage." Johnson keyed his microphone. "Wolfpack, this is Johnson. Execute Zulu pattern now. Maintain formation integrity in the T to the deity. Dive. Remember, they can't catch you coming down." The 16 Thunderbolts rolled inverted in nearly perfect synchronization and pulled smoothly into a 45-degree dive, their R-2800 engines thundering at full military power as they accelerated toward the climbing German formation. What followed demonstrated with dramatic clarity how theoretical test results could translate directly into combat effectiveness. The Thunderbolts screamed downward at speeds approaching 500 miles per hour, their greater mass and aerodynamic efficiency in the dive creating an acceleration advantage the German pilots couldn't match. By the time Johnson's formation reached firing position, they'd built a speed differential of nearly 70 miles per hour over the German fighters, who found themselves unable to maneuver effectively against the diving Americans. The first pass shattered the German formation, with 7 Focke-Wulfs spiraling earthward, trailing smoke and flames. More importantly, The Thunderbolts maintained such high speed through the attack that the surviving German pilots couldn't effectively pursue as the Americans extended away, climbing back to altitude using their tremendous kinetic energy. Within minutes, Johnson's formation had regained their altitude advantage and positioned for another coordinated diving attack. By the third such pass, the remaining German fighters abandoned their intercept attempt and scattered, leaving the bomber formation unmolested. Johnson's squadron destroyed 13 Focke-Wulf 190s confirmed, with 4 more probables, without losing a single Thunderbolt. The engagement represented a perfect tactical application of the performance characteristics identified through the Wright Field testing program, the P-47's superior high-altitude performance and diving. Capability had been leveraged systematically to create an overwhelming advantage against numerically superior opposition. News of this lopsided victory spread rapidly through 8th Air Force fighter groups, reinforcing the tactical lessons derived from the testing program. Colonel Preston Piper, Chief of Fighter Operations for the 8th Air Force, issued a tactical memorandum the following week that explicitly referenced both the Wright Field test results and Johnson's successful application. Recent combat experience confirms testing data regarding P-47 high-altitude performance advantages over enemy fighters. Squadron commanders should emphasize maintaining altitude advantage above 28,000 feet whenever tactically feasible, and initiate combat with coordinated diving attacks that exploit the Thunderbolt's superior diving acceleration. The significance of these tactical refinements extended far beyond individual combat victories. By systematically understanding and exploiting the specific performance advantages American fighters possessed over their German counterparts, 8th Air Force, fighter groups dramatically increased their effectiveness as bomber escorts the primary strategic mission that would ultimately determine the success or failure of the daylight precision bombing campaign. Lieutenant General Jimmy Doolittle, who had taken command of the 8th Air Force in January 1944, recognized that the key to reducing bomber losses lay in aggressive fighter tactics that destroyed the Luftwaffe before it could engage the bomber formations. His controversial decision to free the fighters from close escort duties allowed American fighters to seek out and destroy German interceptors, rather than remaining tethered directly to the bomber boxes. The detailed performance data derived from the Wright Field testing program provided scientific validation for this tactical approach, demonstrating conclusively that American fighters, when operated in accordance with their specific performance advantages, could consistently defeat German opposition. Major James Howard, who had participated in the comparative testing at Wright Field, drafted a comprehensive tactical analysis that became required reading for incoming replacement pilots across all 8th Air Force fighter groups. German fighters still pose a serious threat when encountered under conditions favorable to their specific performance characteristics, Howard wrote. However, systematic testing has identified specific tactical approaches that negate these advantages. P-47 Thunderbolts operating above 25,000 feet possess decisive performance advantages in diving attacks that cannot be effectively countered by either Messerschmitt 109s, Focke-Wulf 190s. This vertical performance advantage, when properly exploited through coordinated tactics, provides our pilots with the ability to dictate engagement parameters and maintain energy advantage throughout combat. The human dimension of this tactical evolution cannot be overstated. Young, American pilots, many with less than 300 hours total flying time, deployed to combat theaters facing veteran German opposition, often led by pilots with thousands of combat hours and dozens of aerial victories. The systematic understanding of aircraft performance characteristics derived from the testing program gave these young Americans a critical edge, a concrete tactical framework that maximized their chances of survival and success. First Lieutenant William Bowen arrived at the 78th Fighter Group as a replacement pilot in December 1944, having graduated from advanced fighter training at Luke Field just 6 weeks earlier. His training had incorporated the tactical lessons derived from the Wright Field testing program, with particular emphasis on the P-47's diving superiority at high altitude. Within 2 weeks of his arrival in England, Bowen found himself facing a formation of Focke-Wulf 190s while escorting bombers over Germany. "I remembered everything from our tactical briefings," Bowen recalled in a post-mission report. "When we spotted the bandits climbing from 9 o'clock low, our flight lead immediately took us higher instead of diving to engage. We climbed to 30,000 feet, maintained our energy advantage, then executed a coordinated diving attack just like we'd practiced. The Focke-Wulfs couldn't match our dive rate. We blew through their formation so fast they barely had time to react. I got 1 confirmed, and our flight of 4 claimed 3 destroyed without taking any damage." Stories like Bowen's multiplied across fighter groups as the tactical lessons derived from systematic testing became fully integrated into operational doctrine. The impact extended beyond individual combat effectiveness to influence broader strategic outcomes. German fighter losses mounted steadily through late 1944 and early 1945, creating a devastating attrition spiral that the Luftwaffe couldn't escape. As experienced pilots were lost, training programs shortened due to fuel shortages, and replacement pilots arrived at frontline units with increasingly inadequate preparation. Major General William Kepner, commanding the 8th Air Force's 8 Fighter Command, summarized the strategic impact in a January 1945 assessment. "The systematic exploitation of our fighters' specific performance advantages has fundamentally altered the air war over Germany. By engaging consistently from positions of tactical advantage, our groups are destroying the Luftwaffe's fighter force at a rate they cannot sustain. The scientific understanding of comparative aircraft performance derived from our testing program has directly contributed to this success, providing our pilots with specific tactical approaches that maximize their effectiveness while minimizing their vulnerability." The human cost behind these tactical developments cast a somber shadow over the technical achievements. For every captured German aircraft that provided valuable intelligence, dozens had been shot down in furious combat, their pilots killed or captured. For every American test pilot who meticulously documented performance characteristics in controlled conditions at Wright Field, hundreds of operational pilots fought desperate battles over hostile territory, where a single mistake meant death or imprisonment. The cold, analytical language of test reports and tactical bulletins belied the brutal reality of aerial combat, the terror of watching tracers stream past the canopy, the sickening lurch as aircraft tumbled out of control, the columns of smoke marking where men and machines had fallen from the sky. The systematic testing program sought to minimize these losses through improved tactical understanding, but could never eliminate the fundamental dangers of warfare. Captain David Jenkins of the 359th Fighter Group expressed this duality in a letter home after a particularly violent air battle over Dresden in February 1945. "We're fighting this war with slide rules and test data as much as with guns and courage. The intelligence officers brief us on exactly where our Thunderbolts outperform their Focke-Wulfs, and we plan our tactics accordingly. It gives us an edge, knowing precisely where we hold the advantage. But when the shooting starts, it still comes down to split-second decisions and raw nerve. The test reports can tell you where to fight, but they can't fight for you." As winter 1945 gave way to spring, the cumulative impact of the Allied air campaign became increasingly apparent across Germany. Luftwaffe opposition dwindled steadily, with fewer interceptors rising to challenge the bomber formations that now crossed German airspace with near impunity. German aircraft production continued at surprisingly high rates despite intensive bombing, but chronic fuel shortages kept many new fighters grounded. More critically, the Luftwaffe had lost its core of experienced pilots, the irreplaceable human capital that had made it such a formidable force earlier in the war. Colonel Richard Turner, an intelligence officer with the 9th Air Force, captured this transformation in a March 1945 assessment. German fighter operations have fundamentally changed over the past 6 months. Where once they mounted coordinated large formation intercepts against our bomber streams, They now operate in small, scattered groups that avoid sustained engagement. Captured pilots increasingly report minimal training hours, fuel restrictions that limit practice flights, and operational directives that prioritize pilot survival over aggressive tactics. The Luftwaffe, as an effective fighting force, is essentially finished, though individual units continue to mount local resistance. The Wright Field testing program continued operating into early 1945, expanding to include evaluation of the latest German fighter types as they became available through capture or defection. Several Messerschmitt Tu-62 jet fighters underwent extensive testing, providing critical intelligence about this revolutionary technology. However, the fundamental tactical lessons derived from earlier comparative testing between the P-47 Thunderbolt and Focke-Wulf 190 remained relevant throughout the war's final months, continuing to shape operational doctrine and pilot training. As Allied armies advanced deeper into Germany from east and west, the last remnants of the Luftwaffe found themselves squeezed into an ever-shrinking operational area. Fuel became so scarce that many units could mount only token resistance against the overwhelming Allied air presence. Young, inadequately trained German pilots faced veteran American fighter groups operating with scientific precision and overwhelming numerical superiority, a combination that produced grim, predictable results reflected in the increasingly lopsided combat statistics. The final irony emerged in the war's closing weeks, as handfuls of advanced German fighters, the Focke-Wulf 190D Dora series and the Ta-152 high-altitude interceptor occasionally appeared over the battlefield. These aircraft represented the culmination of German fighter development, incorporating lessons learned from years of combat experience. They possessed performance characteristics that could challenge even the latest American fighters, particularly at extreme altitudes where their specialized superchargers maintained power more effectively than earlier designs. However, these technical achievements came too late to influence the war's outcome. The systematic degradation of the Luftwaffe's human capital, its experienced pilots, instructors, and ground crews, couldn't be reversed through technical innovation alone. The handful of veteran pilots who received these advanced aircraft sometimes achieved impressive local successes, but couldn't alter the strategic reality of overwhelming Allied air superiority. In April 1945, as American forces pushed toward central Germany, the Wright Field testing program received one final intelligence prize, a captured Ta-152 Hone, the most advanced German piston-engine fighter developed during the war. The aircraft had been abandoned at Leck Airfield when its pilot defected with several others, flying a Junkers Ju-288 to British territory. Technical teams secured the aircraft, which was remarkably intact, and prepared it for shipment to the United States. Unlike earlier captured aircraft that underwent immediate operational testing, this final prize arrived too late to influence the European air war's outcome. By the time preliminary evaluation began, Germany had surrendered unconditionally, bringing the war in Europe to its formal conclusion. The aircraft would eventually undergo extensive testing at Wright Field, but as a technological curiosity rather than an operational threat requiring tactical countermeasures. The human stories behind the testing program reflected the war's broader narrative of technical innovation, personal courage, and irrevocable change. Major Robert Cullman, who had supervised the initial evaluation of the captured Focke-Wulf 190 at Wright Field, returned to his family's manufacturing business in Connecticut after the war, bringing with him management techniques learned through the systematic aircraft evaluation program. "We approached manufacturing problems the same way we approached aircraft testing," he later explained. "Break complex systems into understandable components, test methodically, document results, and implement improvements based on data rather than assumptions." Captain James Howard, the P-47 test pilot who had flown numerous comparative missions against the captured Focke-Wulf, returned to commercial aviation after the war, eventually becoming a senior captain with Trans World Airlines. His experience with systematic aircraft evaluation shaped his approach to civilian flight operations. particularly his emphasis on comprehensive pilot training based on thorough understanding of aircraft performance characteristics rather than rote procedures. For the German pilots whose aircraft had been captured and evaluated, the war's end brought varied fates. Many remained in Allied prisoner of war camps until 1946 or later, eventually returning to a homeland transformed by defeat and occupation. Some found their technical knowledge valued by the victorious powers, particularly the United States and Soviet Union, who competed intensely to acquire German aerospace expertise for their own military development programs. The systematic approach to tactical intelligence gathering represented by the Foreign Aircraft Evaluation Program continued into the post-war era, becoming institutionalized within the newly independent United States Air Force. The methods pioneered during World War II for evaluating captured enemy aircraft would prove invaluable during subsequent conflicts, particularly the Korean War, where captured MiG-15 fighters provided critical intelligence about Soviet jet aircraft capabilities. The legacy of these wartime testing programs extends into modern military aviation, where systematic performance evaluation and data-driven tactical development remain fundamental to combat effectiveness. The basic principle established during those test flights at Wright Field, that specific performance advantages can be identified through systematic testing and exploited through appropriate tactics, continues to shape air combat doctrine across the world's air forces. Perhaps the most profound legacy lies in how systematic technical evaluation transformed aerial warfare from an individualistic pursuit dominated by ace pilots into a team effort, integrating scientific analysis with operational experience. The young American pilots who flew into combat over Germany in 1944 carried with them not just their personal courage and skill, but the collective wisdom derived from systematic evaluation of aircraft performance, a force multiplier that helped overcome the experience advantage many German pilots possessed. When Major Robert Johnson positioned his formation of Thunderbolts at 30,000 feet that November day in 1944, he acted not merely on personal instinct or general tactical principles, but on specific scientific understanding of his aircraft's performance envelope relative to his opponents. The devastating success of his squadron's diving attacks on the German formation represented the practical culmination of a process that began with technical evaluation of a captured Focke-Wulf at Wright Field months earlier. This transformation from individual heroics to systematic exploitation of technical advantages parallels broader changes in warfare during the 20th century. World War II witnessed the full integration of scientific methodology into military operations, from the Manhattan Project's development of atomic weapons to the systematic analysis of aircraft performance characteristics. Technical expertise became as crucial to victory as traditional military virtues like courage and leadership, a change that would accelerate through subsequent decades as warfare grew increasingly technological. The young American pilots who benefited from the testing program represented a new kind of warrior, technically educated, systematically trained, and equipped with specific tactical knowledge derived from scientific evaluation. They fought with slide rules and test data, as well as with guns and courage, applying analytical understanding to the chaotic reality of aerial combat. Their success demonstrated the power of this integrated approach, combining human skill and courage with systematic technical knowledge. As the last Thunderbolts returned to their bases across England and France following Germany's surrender in May 1945, they carried with them the accumulated wisdom of hard-won combat experience, scientific evaluation, and systematic tactical development. The pilots who flew these powerful fighters had participated in a transformation of aerial warfare, integrating technical analysis with operational experience to create a devastating fighting force that had helped secure Allied victory. The captured Focke-Wulf 190, that had revealed so much about German fighter capabilities, eventually found its final resting place at the Smithsonian's National Air and Space Museum, where it remains today as silent testimony to this pivotal chapter in aviation history. The aircraft that once challenged American fighters over Europe now serves as a historical artifact, helping future generations understand the technical and human dimensions of the greatest air war in history. The systematic evaluation of this captured fighter against the P-47 Thunderbolt had produced specific tactical knowledge that directly influenced combat operations, potentially saving countless American lives while contributing to the Luftwaffe's ultimate defeat. The discovery that Thunderbolts consistently outdived Focke-Wulfs when starting from 28,000 feet represented more than an interesting technical footnote. It provided a concrete tactical advantage that American pilots exploited repeatedly during the war's final months, helping secure control of the skies over Europe and paving the way for Allied victory. In this marriage of scientific methodology with operational experience, we find one of World War II's most important and enduring legacies. The recognition that modern warfare requires both heroic human qualities and systematic technical understanding, courage and calculation, daring and data integrated, into a comprehensive approach that maximizes strengths while minimizing vulnerabilities. The young pilots who flew their Thunderbolts into battle armed with this understanding represented the vanguard of a new era in military aviation, where technical knowledge became as crucial as flying skill and fighting spirit. The story of captured aircraft testing reminds us that behind the dramatic air battles and headline victories lay a foundation of methodical analysis, systematic evaluation, and scientific understanding, the often overlooked intellectual infrastructure that helped transform raw courage and technical capability into strategic success. In honoring the pilots who fought these battles, we must also recognize the test pilots, engineers, and intelligence officers whose meticulous work provided the knowledge foundation upon which combat tactics were built and refined. As the world emerged from war's devastation in 1945, this integration of scientific methodology with military operations would accelerate dramatically, particularly in aerospace development. The knowledge gained from evaluating captured German aircraft would directly influence American fighter design for decades, while the systematic approach to performance evaluation and tactical development would become institutionalized across the world's air forces. The lessons learned through blood and fire over Europe, including the specific insight that P-47 Thunderbolts could consistently outdive Focke-Wulf 190s when starting from 28,000 feet, would be studied by subsequent generations of fighter pilots and aircraft designers, contributing to an evolving body of knowledge about air combat that continues to shape military aviation in the 21st century. Thank you so much for watching until the end. If you loved this story, check out the other videos on your screen now. I think you'll really enjoy them. And don't forget to subscribe if you haven't already. See you in the next story.